The internet has become essential to us, but a lot of us still don't know how it works. Okay, I need you to close your eyes. Just trust me, just close your eyes. Yeah, for real, I'm serious. Close your eyes.
What's the craziest thing she could show us when we open our eyes? I hope it's kittens.
Okay, now you can open them.
Tiny people.
They're us.
It's tiny us.
So I know that there are three major parts of the internet. We are on this outer ring. They call it the last mile, but really it's the first and last mile. So it's the texts we send, the notifications we receive, the apps we use. Everything we do to connect or receive information from the internet happens in this first and last mile. And we are inside the box office. Also out in this outer ring are houses, and you guys want to help me put these down?
Yes,
so
trees.
all of the trees and all of the houses, all Wi-Fi, which uses routers somewhere in our office or somewhere in your home, and all cell service, which means that you're pinging a cell tower a little bit further away, but still pretty close by. All this wireless technology uses radio waves to send signals into and out of the internet. I'm going to show you how this works. But first, I'm going to take a selfie. So I'm just going to send this to you via email.
Typical email.
Typical email.
There it is.
Boom.
Ta-da.
So my goal is to figure out how my email got from my phone to yours. In order for my email to get from here to here, my phone takes that photo and cuts it up into more manageable packets. So imagine each packet like a letter in an envelope. So if each envelope gets a header, which is a little bit more information that includes
Where it's from.
and where it's going to, and a bunch of other things that we're not going to talk about. So the format of each header follows a set of rules, and you can think about these rules like the rules of the online postal system, how everything is packaged and sent and received on the internet. So you've probably heard people say that everything that happens in our computer is ones and zeros. Okay, so each one or zero is a bit, and 8 bits is a byte. So if this photo was 1.1 megabytes, that's 8,800,000 ones and zeros.
So somehow these binary ones and zeros have to get onto radio waves to be transported to the router.
How does a wave carry binary information?
That is a very good question. So the simplest thing you could do is every time you want to transmit, say, a 0, you could transmit one frequency. And every time you want to transmit a 1, you transmit a different frequency. And then as long as the receiver can detect which frequency it is, it can know it's a 1 or 0. That's actually called frequency modulation.
Is it also fair then to say that at its most basic, a cell phone is a radio?
And it is a radio. It is absolutely a radio.
Okay, so waves with binary information have to get from my phone to the router, but then at the router, they have to be turned into something else that can go out the back of that device along cables to get to their next location. Depending on what the wire is made of, it's either going to be pulses of electricity if the wire is copper, or pulses of laser light.
So it's a laser, and it just turns on when there's a 1 and turns off when it's 0.
So our photo went from binary to radio waves to little flashes of laser light, right?
Yes.
Where does it go after that?
So the wires out of the back of our router connect to other wires inside our office, which are owned by our internet service provider, or ISP. And they're responsible for looking at the header of each of those envelopes and figuring out the most efficient route to get to its next location, which is an internet hub.
And where would that be?
Right there. That's an internet hub.
This old building?
Yeah.
Well, it started as Western Union's headquarters, so it supported telegraph operators back in the day, and it's migrated to today where it's supporting the internet here in lower Manhattan.
So all those wires all need to come to a place like this to connect between networks. So for example, our ISP in the office has a network, and AT&T, which is Christoph's cell provider, has a network. And in order for my email to get from my phone into Christoph's phone, all of those networks have to send those ones and zeros across those wire pathways.
So there's really no such thing as a cloud or any type of magnanimous
The cloud
floating-
is a marketing term.
Yeah.
The thing that I find really amazing is that, like, my email is one of the millions of messages flowing through these cables. You know, that feels really abstract, but it's actually, there's a message to somebody's mom, and there's a college application, and there's a job offer. Okay, so my email became a series of waves of light that travels over the tubes of the internet. But what if I wanted to send it somewhere really far away, somewhere on the other side of the world? We're in Newington, New Hampshire, to go to a factory that's going to show us how the internet works at long distances. We're headed into the third layer, the internet backbone. The company we're going to go see, Subcom, is one of the top 4 submarine cable providers in the world. The engineering and material science at work here are incredibly complex. But the basic process is actually really simple. Light goes in on one side of the ocean and comes out on the other. So as the Decisive moves across the ocean, the internet cable is going to come out the back and be laid down behind it, and sometimes it's going to be buried in the ocean floor by that machine right there. But most of the time, it's just going to lay there on the bottom of the ocean.
So these are the 2 types of cable that we have, the 2 basic types. So this one is called lightweight cable. So that's the one that we would use in the middle of the ocean. And then this piece is the stuff that we use the plow to install and actually bury. And the cable is engineered to be super strong in a lot of ways, but it is also very delicate in a lot of other ways.
The wires that carry the light waves themselves are typically made of fiberglass, literally just a continuous strand of glass about the size of a human hair. Why is it that there are so few fibers?
We're working on trying to put more fibers inside the cable to get more data into each fiber to make it so that we can send more information on what we already have. That's the cable tank.
What blows me away is just how much hard physical labor is required to make the internet work. Am I? Thank you. The craziest thing is that this cable is one of about 400 exactly like it that create a web around the Earth.